The following video will present solutions to the QCE Year 12 Mathematical Methods Sample Assessment 2020, Paper 2, Technology Active, questions 11 to 14. The technology utilised is the Casio CG50AU graphics calculator running operating system 3.2. Unless specified otherwise, default settings have been used. Question 11. This question involves working with the logarithmic relationship. Part A. We need to determine p given a probability of 1 in 100,000 or 0.0001. This can be directly calculated using the Run Matrix app of a Casio CG50. This gives us a p-value of 0.06. In Part B, we need to consider the effect that increasing the p-value by 2 will have on the probability. If we notice that the relationship in question is essentially of the form b equals log base 10 of a, which is equivalent to a equals 10 to the power of b, then increasing b by 2 units increases a by 2 powers of 10. i.e. by a factor of 100. Not a factor of 1000, which is 3 powers of 10. Another approach to this question is to assign p the value of 2.06, the answer from Part A increased by 2, and then solve the resulting equation for probability pi. One way to solve this equation is to rearrange it to find pi, the probability. This can be done by raising both sides to the power of 10 and then multiplying both sides by 8.71 times 10 to the minus 6. This solution shows that a p-value of 2.06 corresponds to a probability of approximately 0.001 or 1 in 1,000. This is 100 times more likely than the probability in Part A, not 1,000 times as John believed, so we can conclude that John's belief is incorrect. The equation under consideration can also be solved using the Solver app of a CG50. To do this, open the equation mode from Main menu and then select Solver by pressing F3. Enter the equation needing to be solved. The equals sign is entered by pressing Shift and the decimal point key. I'm going to use p as my unknown. This is entered by pressing the red alpha key and pressing 4. The solver uses a numerical process to search for solutions within a given domain. As our solution will be a probability, a solution domain between 0 and 1 would be suitable. Enter this by arrowing down and setting lower and upper bounds. Press F6 to solve this equation. Question 12. Part A. This context, the number of universal donors within a random sample of 45, can be modelled by a binomial distribution because the creation of such a sample can be thought of as a fixed number of independent trials, 45, where each trial has exactly 2 outcomes, being whether the donor is universal or not. The selection of a sample such as this from a finite population is not strictly independent. The probability of selecting a universal donor as part of this sample is affected ever so slightly by the number of universal donors that have already been selected in the sample and hence are unavailable for selection. However, Given the large size of the Australian population relative to the sample size, this changing probability p as the sample is drawn will have negligible effect on the results obtained, and so the binomial distribution should still prove to be an accurate model. Part B. The mean and standard deviation of this binomial distribution can be calculated using the formulas mu equals np and sigma equals the square root of n by p by 1 take p. These can be evaluated using n equals 45 and p equals 0.09. Part C. This part asks us to consider the situation where x, the number of universal donors within a sample of 45, is no more than 3. This means that x is distributed binomially with n equals 45 and p equals 0.09. We are interested in the probability that x is less than or equal to 3. This probability can be calculated using the statistics app of a CG50. Open the distribution menu by pressing F5 and select the binomial distribution by pressing F5 again. To perform a cumulative calculation such as this, select BCD by pressing F2. Set the data to variable by pressing F2. As we want the probability between 0 and 3 inclusive, these are our lower and upper bounds. Enter the number of trials n and probability p. Press execute. Question 13. Part A. The function m of t is easier to differentiate if rewritten as 16 plus 3t squared to the power of minus a half. The derivative of m of t can be found using the chain rule for differentiation. dm by dt equals minus a half by 16 plus 3t squared to the power of minus 3 over 2 multiplied by 6t, the derivative of the inner part of function m. This can be simplified to minus 3t by 16 plus 3t squared to the power of minus 3 over 2. Part B. The integral required in Part B differs from the result in Part A only by its coefficient, 1800. As 1800 is equal to minus 600 times minus 3, we can rewrite n of t in terms of the result in Part A as follows. Now that we have our integral expressed in terms of the derivative from Part A, we can see that n of t is equal to minus 600 times m of t plus c, the constant of integration. Part C. Given the initial information about n of t, the derivative n dash is the expression being integrated, so the value of n-4 can be found by substituting 4 into this expression. This can be evaluated using the Run Matrix app of our Casio CG50. Part D. Our expression for n of t, as found in Part B, includes c, the constant of integration. The value of this constant can be found using the information provided about the function. In this case, the fact that n of 0 equals 0. Based on this, we can write the following. Hence, c equals 600 divided by the square root of 16 which is 150. Now that the constant of integration has been found, n of 4 can be determined by substitution. This can be evaluated on our CG50. Another approach to Part D is to revisit the definition of n of t as the integral of a rate function. As such, the total increase in n between time t equals 0 and time t equals 4 can be calculated as a definite integral of this rate function. N of 4 will be equal to n of 0, which is 0, plus this definite integral. This definite integral can be evaluated on our CG50 via the Math menu and the definite integral template, which is found via F6 and F1. Enter the rate function. Arrow right to move through the template, entering lower and upper bounds. Press execute. This returns the same value for n of 4 that we calculated previously. This question refers to two possible triangles with the information given. These triangles could look something like this. The mathematics around finding the unknown side and angles for these two cases is sometimes known as the ambiguous case of the sine rule. The sine rule looks like this. This can be rearranged to find angle C. Evaluating this expression on our calculator will give the smallest possible angle C that fits this information. Before I evaluate it, I will need to change my angle measure from radians to degrees. Do this by opening the Setup menu via Shift and the menu key, arrow down to Angle, select Degrees. Now enter the expression to be evaluated. Because of the symmetry of sine either side of 180 degrees, the obtuse angle C can be found by calculating 180 degrees minus the acute solution. The last answer command, called up via Shift and the negative key, is useful for these sorts of calculations. Now that we have the two possible values for angle C, we can use the angle sum of a triangle to find angle B. Now that angles B and C are known, the sine rule can be used once more to find side length B. By rearranging and substituting, the two values for side length B can be found. There are other approaches to finding the unknown sides and angles in this question. The information provided could have been substituted into the cosine rule to generate a quadratic equation in terms of b. This equation can be rearranged into general form. Quadratics in general form like this one can be solved using the equation app of the Casio CG50AU. Select the polynomial solver by pressing F2 and choose degree 2 by pressing F1. Enter the coefficients a, b and c from your quadratic in general form. Press F1 to solve. With these two values for side length b, we could then use the sine rule to find angle b and c and continue from there.